All right, let's wrap up this partial fraction stuff. So, recall where we're at. Where are we at? There we are. Hey, so we have the negative natural log of the cosine of theta, but we want our x's back in there. And from our substitution, we let x equal the 2 times the tangent of theta. We need to find the cosine of theta. So here's what we've got. We've got x over 2 equals the tangent of theta, so we can draw a triangle for that. Whoops. Okay, there's a right triangle. Let's call this angle theta. If the tangent of theta is x over 2, that's opposite x, adjacent 2. We want to find the, where is it? Cosine of theta. So we need to know the hypotenuse. Well, the hypotenuse is going to be using the Pythagorean theorem, x squared plus 2 squared equals hypotenuse squared. So this is the square root of x squared plus 4. So the cosine of theta equals the square root, adjacent over hypotenuse 2 over the square root of x squared plus 4. So we're going to put this in as 2 over the square root of x squared plus 4. Now let's finish. Let's distribute the 1/2 to this theta. But what is theta in terms of x? There it is. Well, if we take this step and we take it one step further, the arctangent of x over 2 is theta. And that's what we have. Now, there are certainly more things that we can do, and I've kind of neglected that because these videos get really long already, but we could use properties of logarithms to do quite a bit of simplifying. But I'm just going to stop right there for time's sake. Let's do one more, but not the full problem. Let's just make sure we can set it up. What happens if you have an x squared plus 1 squared? How would you set up your decomposition? Well, I have a factor of x squared plus 1 in the denominator. That's a quadratic factor. That can't be reduced anymore. If it's a quadratic factor, it would have a linear numerator. So I'm going to call that linear numerator ax plus b. Now this is repeated twice. So we did the x squared plus 1 to the first. Now we do the x squared plus 1 squared. And again, that's a quadratic factor in the denominator, so it gets a new linear term in the numerator, which we would, I'm at the letter C now, so I would say cx plus d. So I just wanted to show you real quick how you would set up another partial fraction so you could solve this one for a, b, c, and d. So that's going to be a wrap on my videos on partial fractions. Make sure that you're working hard, pulling in all those different resources of things you already know how to do. I mean, seriously, don't you feel smart? Look at this problem. Don't you feel smart? Okay, just what you're able to work through, all the different skills that you have that you're able to get yourself through to get that problem. Hey, I'm proud of you guys. Great job. Keep up the good work.